Hi everyone, and good wishes for Dr. LATIF, AZYZE, BEKM, and SHAARI. Today we are going to talk about our home automation system for energy efficiency, and we're going to present whatever that we have done on the slide. And let me introduce my teammates. First is NAHVIN SEKARAN, and NITHYA SIVARAMAN, and myself RUBEASHNAIR, and last is Kishen Rajandren. And for today's slide, let me have some introduction about our topic, that is home automation system for energy efficiency. It is a controlled with sensors that can reduce our usage and increase the efficiency of daily usage of current in our home. And the problem statement for our project is environmental concerns, how it affects the environment by reducing the voltage usage, also the current production. And common issues in homes where like you used to forget to switch off fans, lights, or any other electronic appliances. This project might help to reduce all these problems and find a good solution in behalf. And the next we move to proposed solution, which is like the solution we have is a microcontroller based home automation. We use some sensors and we used some of the data to collect and automation systems to switch off and maintain the good efficiency, the usage of current. And the benefits from this project is we can literally find the problem and find the solution by integrate this production of this project with a minimized cost and to avoid the rising electricity costs is one of the problem statement and the last statement that I have stated in this slide. So that's it from my section. Let me move to Navin. He'll continue after this.
Thank you, Rubesh. Let me introduce myself first. My name is Navin and my registration number is B0122101117. Today, I'll be presenting a solution to address energy inefficiency in homes through smart automation technologies. So before that, this is our philosophy table and we have come up with 4 solutions. And we have chosen only one of the solutions because it is the most suitable one for our projects. Our system focuses on automating lights and fans and cooling system to reduce unnecessary energy use. We have incorporated VIR sensor to detect motion and occupancy. This ensures that lights and fans automatically turn off when no one is in the room, cutting down on power wastage. Additionally, TNP36 temperature sensor monitor room temperature and adjust cooling system such as fans or air conditioning, ensuring they operate only when necessary. This creates a balance between comfort and energy efficiency. So, for the design, we have integrated an Arduino Uno R3 as a systems brain, which reads data from the sensors and decides the state of the appliances based on predefined conditions. The LCD 16x2 I2C displays provides real-time updates on the appliance status, while a breadboard connects all the components, including LEDs and resistors, for prototyping. In summary, this system offers a practical and sustainable way to enhance energy efficiency in homes. It not only reduces electricity costs but also supports eco-friendly living by ensuring appliances are used only when needed. That's all from me. Thank you, and I pass the next part to my friend Nithya.
Thank you, Navin. First, let me explain about the programming code for project home automation system for energy efficiency. So this is the coding for project. As you all know, we have used LCD I2C, temperature sensor, VIR sensor, and also LDR, and we also use 2 colors of LED, which is represent the fan and also the light. So first, we have defined the I2C LCD library, and then we define all the pins that we use in this project. And in this coding, we have defined the Boolean function, which is used to track the state of the light and also the fan. So, which means if the state show false, means the light or fan is off. If true, means it's on. So, the coding is divided into 2 parts, which is first is to control the light, and also the second part is to control the fan. So, the first part, the light is we use motion sensor and also the LDR sensor. So, for the light level, we set into 500, which means if the level below 500, it means the room is dark. If above 500, it means the room is bright. So for the fan, we have set the temperature to 30 degrees, which is below 30 means the room is in normal temperature or cold temperature. If above 30 means the room is in hot temperature. We also set this coding to display the status of the fan, also the light time to time. So the display will show the fan is and the light is on or off. So for the last part, we have put some delay of 500 milliseconds for the stability of the coding and also the project. So without any further delay, let me show you the simulation and explain how the project works. This is the final circuit of our project. We use Tinkercad to build this circuit. So as I mentioned in the coding, we have used the components. So this is the I2C LCD, the Arduino Uno, the LDR, the motion sensor, PIR sensor, the temperature sensor, and we use the yellow color LED for the light and the green color LED for the fan, which means if the light LED blink, means the light is on. If the yellow color LED is off, means the light is off. Same goes to the fan. So when I start, already I inserted the coding. So when I start the simulation, so it will show the welcome page home automation system for energy efficiency. After that, it start to show the status of the light and fan. For now, the status for the light and fan is off. So let me test the light first. So if the LDR sensor shows the light level low, which means the room is considered dark. But when the room is dark, the light still is off. It didn't get on because we joined the LDR sensor with the motion sensor. And the room is dark and it detects some motion, then only the light gets on. So whenever the bright, so I turn the LDR sensor to bright side. So if detect any motion, so the light will off. So it means it didn't get on. So it means if a person walking into the room in a dark situation, then only the lights get on. If the bright situation means the light remain off, it didn't get on. So for the fan, we use the temperature sensor and also the PIR sensor. So the temperature that we set for this fan is 30. So now the fan is in 25 Celsius, which means the room is in a normal temperature or cold temperature. So if the room temperature is 25, if the PIR sensor get any detection, so the fan is not start because the room in cold temperature. If I change the temperature to above 30, which means the 41, I set to 41. If it get any motion, so the fan will start to rotate. It means it's considered the room is hot. If the person enter the room, the fan will start. So this is the concept of our project. By this, we can reduce the unwanted light on and fan on. We also give the energy in our house. So that's all from me. Thank you. Let me pass to my teammate Kishen.
Thank you, Nithya. My name is Kishen Rajandren. Today, I would like to explain about conclusion and recommendation. In conclusion, microcontroller-based home automation is an important step toward making buildings more energy efficient. It uses IoT, sensors, and automation to reduce energy waste and improve comfort. With real-time monitoring and control, energy use can be adjusted based on the conditions or users' need. While basic components were used for testing, real systems can use more advanced parts. This system helps save energy costs, lower carbon emissions, and support global sustainability. It shows how modern living and environmental care can work together, leading to a smarter and greener homes. Recommendation. To improve energy efficiency in a home automation system, smart devices like thermostat and adaptive lighting should be included. A real-time energy dashboard can help users track and manage energy use to reduce. Adding renewable energy sources like solar panel can lower reliance on traditional energy. The system should always be modular, allowing easy upgrades or expansions. These steps will help us to save energy, cut costs, and support a greener environment. That's all from us. Thank you.